This is section 7.6 for pre-calculus, and so we've learned all the different pieces, A, B, C, and D, for a trig function, a sine or cosine function that's in standard form. Okay, so today we talk about what if it's not in standard form, right? Non-standard form. All right, well, first of all, let's look at standard form one more time, just so we can kind of do a comparison. So remember, standard form would be y equals, the a number is in front, I'll use sine, and then you'd have the b out in front of a parenthesis, x plus or minus c. And I would say the b is out in front of the parenthesis if you have a c number, right? Because if you don't have a c number, you don't have parentheses, and then it would just be bx. And then at the end, plus or minus d. So if it looks like this, it's standard form. So look at example 1. How does example 1 look any different? I mean, it still has the a out in front, still has the d over here at the end. Do you see that the difference is right here? The difference is that the b is not factored out of the parentheses. So that's what makes it be not in standard form, which should tell you, in order to graph it, you're going to put it in standard form. So what are you going to have to do to put it in standard form? You're going to have to factor that b number out. So I'm going to leave the a out in front, sine, but I'm going to factor out, if I have 2x minus 4 pi, couldn't I factor out a 2? And then I would have x minus 2 pi, and then plus 2. You might say, well, why do I really have to do that? Because I know that the b is 2, whether it's factored out or not. That's true. But the horizontal shift, if you didn't have it factored out, you might think the horizontal shift is 4 pi, because that's what's inside the parenthesis. But now that you've factored out the b, the horizontal shift is only that minus 2 pi that's inside the parenthesis. So it's the c that's affected if you don't have it in standard form. Okay. So just for practice, let's put this graph on. So let's see, the amplitude is 2, the period is 2 pi over b, so that's going to simplify to be pi. The horizontal shift is 2 pi to the right, and the vertical shift is 2 units up. Okay, so I'm going to mark off my period of pi. These lines look smaller than the other day. This is the sine function. So let's see, my zeros are going to start, end, and halfway at 0. It's going to be a skinny little dude. And then halfway between each of those, I'm up at my amplitude of 2, down at my minimum of negative 2. So there is one section. All right, now I'm going to bring in both my horizontal shift and my vertical shift. So I'm going 2 pi to the right, okay, 2 pi to the right, and at the same time 2 up. So I'm going to start with this one. If I move that 2 pi to the right, there's 1, 2, let's see, 1, that's going to be 2 pi, right? Oh, and then I also want to go 2 up. So I went 2 pi to the right and 2 up. Okay, so I'm going to take this last one. If I go 2 pi to the right, 1, 2, and 2 up, it's right there. Notice the whole thing is going to happen within a distance of pi. Notice there's only 2 lines between those. Okay, now I'll take that middle one, 2 pi to the right, 1, 2, and 2 up, there it is, which makes sense because aren't those zeros all lined up next to each other? All right, and then so if you want, you can picture moving this one, or you can be like, hey, since I know that that 2 happens between those 2 zeros, I can just tell it's right there. And since I know that minimum happens between those last 2 zeros, I can tell it's right there. That's why I tend to move the beginning and end or the zeros first, because then you don't really have to mark off those middle points. You just know where they're going to have to land. Okay, so here's my sine function. That's been moved over. Okay, look at example 2. If I put it in standard form, so I'm going to factor out that b, that 2, so y equals, I've got a negative cosine. If I factor out 2, now you might be saying you can't factor out 2 because you can't take 2 out of pi. But remember, in order for it to be in standard form, I have to have an x right here. not a 2x, not a 1, and not a half x, but an x. So whatever number is next to the x, whether you think you can factor that or not, is what you have to factor out. Okay, great. So that means here comes the tricky part. Then on the inside, I'm going to have x plus, well, what must be there so that when it gets multiplied by 2, it's going to equal pi? And the way I think of it is, when you factor something out, you're dividing it out. So if I divide a 2 out of pi, I'm going to have pi over 2. You can always check. If you distribute the 2, will you have 2x plus pi? Yep. Okay. And so remember, you're only factoring it out of the parentheses, and so I still have the plus 1 at the end. Now, because we've been practicing all of the graphing on this, I'm going to let you handle that graph. I'm going to let you go ahead and do the graphing on it, and I'll just help you practice putting these in standard form. Because then if you forgot how to graph, then just go back and watch the previous video, the 7.5 video, to help you remember how to graph. Okay, so look at number 3. I can tell it's not in standard form because the b is not factored out. So y equals, leave the a, cosine. So again, I don't care that both of them have a 1/2. The fact that there's a 1/2 in front of the x tells me I have to factor out a 1/2. Luckily on this one, it's going to be easy to factor out. It's going to leave me just with x minus pi, and then I have my minus 1. And maybe I'll help you just fill in the information and you can do the graph. So on this one, remember the amplitude is 3. The period, remember, is 2 pi over b, so over 1/2. And if you think of that as like a fraction over a fraction and do outer over inner, that's going to come out to be 4 pi. My horizontal shift is now pi to the right, and my vertical shift is 1 unit down. Okay, so let's talk about the factoring on number 4. So if I take out the b number, so y equals -3 sine, so whatever number is next to the x is what's coming out. So I'm taking out a 1/2. Again, on this one, luckily it's going to factor out easily. I'm just going to have x plus pi. And then at the end, I still have a -2. Okay, so let's practice putting it in standard form on example 4. Okay, so I've got y equals, leave the a number of 1/2, sine. Now, here's my parenthesis, so I've got to take out whatever number is next to the x, so I'm going to factor out a 2. So I know it's going to be x minus something. Remember what we said, factoring out a 2 is the same as dividing by 2. So when I divided 2x by 2, I just got x. And when I divide pi by 2, I've got pi over 2. And there was no number at the end, which tells me there is no vertical shift. Okay. And then let's look at number 5. So is this in standard form? And you might be saying, well, there's no parentheses. Okay, there's no parentheses, so it's kind of like saying the only parenthesis is right there around the x, because that +3 is definitely not in a parenthesis. Otherwise, you'd see the parenthesis there. So in this case, there's nothing to factor out. It's already in standard form. So just to help you kind of think it through, the amplitude is 1/2. The period is 2 pi over 1/2. And up above, when we simplified and thought of it as outer over inner, it came out to be 4 pi. In this case, there's no c number in the parentheses, so that means there's no horizontal shift. But there is the +3 on the outside, so that means the vertical shift is 3 units up. And since this is our last one, I'll go ahead and help you graph it. So I'm going to put these two on. So if I have a period of 4 pi, so 1, 2, 3, 4, here's my period of 4 pi. This is cosine, and cosine normally starts and ends at its maximum. So I'm going to start and end at a half. halfway, I'm going to be down at -1/2. Halfway between each of those, I'm going to be at 0. So I've got this really squishy, flat cosine graph. Hopefully it still kind of looks like cosine. And then there's no horizontal shift, but there is a vertical shift of 3 units up. So I'm going to move the beginning and ending first. So up 3 units would be 1, let's see, 1, 2, 3. Move this one up 3, 1, 2, 3. If I move this one up 3, 1, 2, 3. And then I'll move those middle ones. So this one up 3 would be 1, 2, 3. And then this one up 3 right here. And so here is my very squishy cosine graph. Again, even though I've even kind of darkened in that graph, I can still see all 5 points. Okay? So that is everything you never wanted to know about graphing sine and cosine from section 7.6.